Hello, hello. Now it works. Great. Okay. Yeah, a very warm welcome on behalf of SEPS and also of myself. My name is Rosanna Fanny. I'm a researcher in the Global Governance, Regulation, Innovation and the Digital Economy Unit, in short, GRID, working here at SEPS, Center for European Policy Studies. And I have the real pleasure today to host this event on future cooperation in 5G and 6G between the EU and Japan. In the beginning, I would really like to thank also the mission of Japan to the EU for making this event possible and yeah, for kindly agreeing to co-host this event. We have today two special guests present here. That is here Professor Aki, as I learned today, Nakao, who joins us directly from Japan. I will give a few introductory remarks also on his bio later on. And we are also very glad to be joined by Bernard Barani from DG Connect from the European Commission, who's also with us today. For the agenda, we will hear first two keynote presentations from the two esteemed panelists. And then I will ask a few questions and then we'll open up the discussion for question and answers with the audience. So keep your questions already in mind. Also to the online audience, of course. This event is also live streamed, just to let you know, and you can also rewatch the event on YouTube. Now we turn to the substance of the event, which is about 5G and 6G and future connectivity. So as we know, the advancement of wireless technology has really opened up a world of possibilities and revolutionized how we communicate, how we commute, how we work, how we drive. It's become a quality of life enhancement that we would never ever envisage, but also we would be so reliant to be upon. And with higher speeds and also greater capacity, 5G technology really brings faster connections, better performance and access to a whole new range of technologies. And of course, beyond the benefits for consumers, also public and private actors will now need to think wisely about what priority application areas 5G should be deployed for. 5G networks are more energy efficient than 4G networks, and could also unlock tons of CO2 savings, which are really instrumental for the green and digital transition. But at the same time, significantly more connected devices and new data, heavy use cases, increase energy consumption. So the key question really is, where does 5G really fit in the future centers of demand for the next decades, and which priority use cases should be deployed? Now when we move to 6G, experts predict that 6G will offer even higher frequency bands and also flexible cloud-based technology to provide speeds up to 100 times more than 5G networks. Such speeds could open up a new way of mobility, including, of course, automated cars, smart homes, industrial applications, and also a range of Internet of Things applications. Also, machine learning and AI technology will play a defining role in the future connectivity mix. Future 6G will, of course, be cloud and AI native, and that means that the network operates on the data collected from all the network segments in order to enable smart resource management and access control and also multi-layer communications. So definitely for the new range of technologies that we already see that are very important today, 6G is a key technology and a key enabler of those new technologies. But as 5G and 6G become already or have become key technologies, their development and use is also subject to geopolitical tensions. Exemplified, for example, by the spotlight placed on Chinese equipment manufacturer Huawei and the security risks associated with its use. Of course, also semiconductors play a crucial role for 5G technology and also are subject to economic and geopolitical strategic discussions. Now, turning to the topic of today, the EU and Japan have published in 2022 a digital partnership, and there also the highlight is cooperation in 5G as a key element. Both sides intend to promote the development and deployment of secure, high-performing, energy-efficient, and sustainable 5G and technologies. Both sides will also work towards a shared global vision of 6G and towards the stimulation of global 6G ecosystems, including standardization. This is all an excerpt from the EU-Japan Digital Partnership, and this is also what brings us together today. With all these elements, I think we can look forward to a very interesting discussion, and I now give the floor to first Bernard Barani. Bernard Barani joined the European Commission in 1994 already, after 11 years as a communication engineer in industry and with ESA. In the Commission, he has been steering wireless research and innovation for more than 20 years, and he currently leads the strategic definition and implementation with industry of the European Research and Innovation Program Smart Networks and Services, 6G. His main field of responsibilities beyond R&D includes standardization, international cooperation, demonstration, and pilot programs. Bernard, the floor is yours.
No, this works. Oh, it works. Okay, sorry for that. So good afternoon, everyone. So I think we had already quite an interesting introduction by Rosaline on the so-called digital partnership. And what I would like to do with you is to share a few ideas on what we are working on in the context of future connectivity systems that we are talking in the Commission at this moment in time. That means 6G. We can discuss 5G if you want as well. We see some deployment or impressive deployments in Europe, but maybe not necessarily at the level we would like. And there are still a few, let's say, steps to be achieved in Europe in terms of 5G deployment, especially for the most advanced version, which is called the SA version, which will in principle bring to the users the most sophisticated set of use cases 5G could enable. But if I could have the slides, is it possible to send the slides and then I can present the, voila, the 6G stuff that we are working on. So I have focused this set of slides on, again, future 6G related systems, because we have been working on this in the Commission for about 3 years now, more than 3 years, trying to ask ourselves what comes after 5G. And this is related to a very simple reality, which is a new generation comes normally every 10 years. So now that end of 2020 or 2010 decades, we see that 5G was in deployment mode. We asked ourselves with the stakeholders, what can we do for the future? What should be concentrate our efforts to define what the future will be? So what we see today is that all over the world, we are not the only ones to ask that question. There are multiple 6G initiatives all over the world, in Japan, of course, but also in South Korea, in China, in the US, which is a little bit more new if we consider that in the early days of 5G, the US were not that proactive to stimulate any action in that field. But these days, they are very serious about it. They have created an alliance called the Next G Alliance, which is looking into it. They have a kind of a research programs through the NSF, which are focused around this. But the situation we have today is that there is no identified pre-commercial or commercial initiative in 6G, which is looming. If you remember the early days of 5G, we had very early announcement by US or Asian operators stating we want 5G in 2018, we want 5G for the Olympic Games here and there. We have nothing of that sort at this moment in time. So there is a real focus in terms of deployment today on 5G. 5G is the focus. And the research community, including industry, of course, is looking into the prospects, what could be the future. We have no established global vision for 6G today. If you remember the early days of 5G, we had the so-called ITU recommendation M2083, the so-called ITU triangle, which was stating these are the services, the vision for 5G. There is nothing like that today. even though many actors in the field have their own vision, and there is work ongoing in ITU to define such a vision. But we don't have that. In Europe, we have one which is, let's say, defined by the so-called 5G public-private partnership, which is an initiative that we launched in the early 2012. But this is not necessarily the vision that everyone shares. I will say a few words on that. We have a lot of technologies being investigated at this moment in time to bring networks towards next generation capabilities. And what we see from our perspective is that we need to work early enough in the process to avoid the fragmentation risks. And this is where we believe that international cooperation has a big role to play, because if we are in the so-called pre-standardization phase today, we have not yet even started. We don't even have a vision, so we have not even started to think really what will go into standardization. We need first to have a global vision, but we need also to have a vision of the ecosystems. If you remember the early days of 5G again, we had a vision, but different regions implemented different ecosystems. So at the end of the day, the US went into fixed wireless access as a strategic priority for their use cases. China went for something else. In Europe, we tried to put more emphasis on verticals and permeating industry. So there was not a real convergence of views on what would be the priority ecosystems. And this is something, if we can avoid that through international cooperation, this is very important in our view. So we need also, in our view, to move towards one global standard. That means to prepare working together at the level of 3GPP when time comes for standardization, this new set of technologies. And also, something maybe we did not do for 5G is to involve from the onset the widest possible industrial base, because we can see that the users we were thinking of at the beginning of 5G are not necessarily the users that we are thinking of today. There are a lot of iterations in that business. So when we look into this, we have also to consider a new global framework, and this was explained in the introduction. First of all, in terms of geopolitics, since the early days of 5G, we have seen the concept of cybersecurity rising in importance, which has been also very much amplified by the COVID crisis. So, which means that from our perspective, we have to work at the level of the supply chain, not only at the layer of the connectivity, but we have to try to reconstruct capabilities in domains such as chipsets, which is very close to the heart of our commissioner, as you know, but also in the service provision capability, which is cloud computing platforms or edge cloud. And this is something we try to have an holistic perspective on that. At the level of industry, we see potentially new players coming in, which is due to the softwareization of the cloudification of networks. You probably all have heard of this Open RAN initiative, so I mean the move towards Open RAN, with different views on how to implement networks, and this is something that already exists in 5G. This is something that we expect will be much amplified in 6G, in future generation networks. So we need to have in Europe also an ecosystem which is prepared to play in this game. That means to play in the industrial, let's say, landscape, which will be composed by a new type of actors, bringing into it, bringing the ecosystems, innovation and new software capabilities. Sustainability, societal issues are something that under the UN SDGs is also something extremely important. We have the Green Deal initiative in the Commission. You probably are all aware of that, but we need to look into how the new platforms will contribute to these sustainability objectives from several perspectives, but I can say a few words if we have time. And users, we have also new type of users coming into play. We have the verticals, but we have also new type of industries which are potentially affected by the deployment of this type of networks, which means that when looking into what future standards could be, what future technology should be, we need to bring into the game. So what we are trying to do in the Commission, on the one hand, the microelectronics industry, the IT industry, and the vertical. So these are the players we are trying to involve in our initiatives. So if I can go to the next slide, but it doesn't work. So it seems to be blocked. Ah, voilà. So from our side, we have launched to start thinking into this and to support research at the level of the union, an initiative called the Joint Undertaking, which has a name 6G SNS, Smart Networks and Services. So this is, let's say, a public-private partnership where the Commission plays the role on the one side of the public sector, and the private sector is represented by an industry association which is called 6GIA, which has today 250 members, let's say the main actors of the telecom landscape in Europe today, but not only European. We have also US companies, Japanese companies, Chinese companies as well are inside. And this is something we are putting together with the member states, with the Commission, with the industry actors, but also with some dedicated stakeholders groups, such as 5G AA in the automotive sector, 5G Asia in the Industry 4.0 sector, and other representations for dedicated sectors of importance, such as public service or public safety community and so on. So we have this initiative operational since the end of November 2021. We inject into it 900 million euros, and the private sector contributes an equivalent amount of money to run projects, but not only projects, also what we call test platforms and infrastructures that can be used for the vertical to test their use cases. So again, the slide doesn't move that fast. Voilà. So, okay, doesn't want to move. Yes, here it is. So I said we have no vision today globally established for 6G. We have, with the stakeholders, established one, which emerges from a set of projects that are on the left-hand side that we initiated in early 2020. And out of these projects, one of our flagship project is called the ExaX. So it's led by Nokia, Ericsson, the vast majority of operators. It has Japanese players inside, which are also represented through the advisory group, where, for instance, NTT Docomo is part of the advisory group to this project. And these people have developed a vision which is not far away from what you can see in other regions of the world. The idea being that in the future, we could have massive digital twinning of the physical world, and also understanding and realizing what is happening in the physical world through their digital representations. And by connecting the intelligence and the data which are coming from these digital representations, we can take actions on the physical world. So we can think of a smart city digital twin that you could use to optimize the traffic pollution or the traffic of the cars, and to minimize a certain criteria that would be the pollution, for instance. So this is the kind of models which are being considered, of course very ambitious, and it is also related to achieving sustainability objectives, and in particular security, trust and resilience. So next slide, but the machine, yeah, voila. So with the stakeholders, we have developed a set of use cases which could represent this let's say, future type of systems. Let's say that if you look at new generation of mobile communications, they always come with three type of features. One type of feature is that it makes possible new classes of applications. That's a new set of, completely new set of applications. Second feature is that it enhances applications that were already possible before. And third feature maybe is that it comes with a new radio technology. I would not comment on the last one, but here the set of new features are features which are basically based on this notion of massive digital twinning of the physical world, such as telepresence, of twinning of smart cities, or these type of things. So there are a number of applications which are today, some of them today are possible. For instance, extended reality applications are possible with 5G. You can even have a 5G demonstration of, let's say, holographic communication that was done, we did it in 2018 already, but it consumes a huge amount of data and a huge amount of, let's say, capacity from the network, which means that the enhancements are needed to make it scalable and to make it commercial and sustainable. So again, trying to move the next slide, voila. So to support this type of vision, we are looking into a number of technologies with the stakeholders. Again, I would not go into the details of all these technologies, maybe it's a little bit too detailed, but there is a kind of perception that a new system architecture is needed if you want to realize this type of things, because you need networks which are extremely flexible and agile, that can be reconfigured according to the type of applications you are running. And people are trying to move towards what they call AI-based networks. That means that the network acts as a gigantic data collection platforms that you can use to learn some behavior on the network, and on this basis you can optimize the behavior of your network and you can optimize the implementation of your network. You see already this type of things happening with artificial intelligence in Open RAN, where they have the RAN intelligent controller, for instance, which is being developed. Or in the core networks with GPP, they have something called the NWDAF, if I remember well, Network Data Analytics Function, which is being deployed for the core network. But this does not give an end-to-end perspective of artificial intelligence. So what people want to have is a kind of end-to-end perspective of how you can use artificial intelligence to manage the full network and not only bits and pieces of the network. This is this idea behind architecture and controls. So network and service security, this is obvious, but this is the kind of things which is amplified by the fact that future network, probably already today, are implemented across a multiplicity of domains. So you can have part of a network implemented with a communication service provider, part of it implemented in an hyperscaler, part of it implemented in a vertical. So you have to cut across a huge number of domains, which means that to get an end-to-end visibility of security is not necessarily something which is super easy. And so on. Non-terrestrial networks, that's the idea of satellites coming for coverage. Radio and signal processing is something that we need to investigate from the perspective of data volumes with new frequency bands and also sensing, because people are trying to consider sensing as one of the features of 6G, and so on. So I will not go too much into the details of this slide. The idea behind, which is being researched today, is that artificial intelligence, as you can see in the middle, is being applied at each and every layer. So for instance, today at the very physical layer, at the very basic layer of radio, there are research to make waveforms, this type of signal you transmit by the radio, agile and reconfigurable according to the channel characteristics and traffic using artificial intelligence, up to the level of the service provisioning, which is this type of intelligent service provisioning that people are considering. So next slide, but again, I have difficulty. Voilà. This is the set of projects we recently started in this domain. So we kicked off this project in January this year. So this gives you an idea of the type of technologies we are investigating, but also the use cases we are investigating. So all these use cases that you see in the middle pie chart are being worked out with vertical companies. So we are trying to make them participate in the system as early as possible in such a way that they can influence the standards and the specifications that will emerge later. In terms of international aspects, it was already presented that we signed a digital partnership with Japan last year in May, and this idea of cooperation with Japan on 6G matters is very explicit in this document. And from our perspective, if we look at the 6G Industry Association, which is the private partner to our initiative, they have signed a number of memorandum of understanding with other regions and also with a number of specific industrial setups. One of them being with Japan, of course, and which is potentially building on issues of global interest, such as how to move towards vision, ecosystem, standardization, all these things that require global perspective and global consensus. And RNI is an interesting platform to discuss because it brings the people around the table and it brings the people exchanging ideas on what can be feasible, what cannot be feasible. So we believe there is a window of opportunity for such cooperation, which extends in the next few years, because if you look at the way people look into it, they believe that the standardization race, let's say, for 6G, what comes beyond 5G, will start with release 20 in 3GPP. That means around 2025. So 2025, we could see the first study items, as they call it, in 3GPP to try to define what is 6G and what would be the set of service and technologies that have to be standardized. And this will be pursued with work item in the later releases. So now we have a good, let's say, timing to discuss with global partners to see what it is that we want and how we want to prepare this standardization race. And again, sorry, it goes. Sorry, it didn't show the last slide, but it comes to the next slide. But doesn't matter. The last slide is very simple. It just says that in our initiative, so that's the one after, we have identified a dedicated, let's say, window for collaboration with Japan in particular. This is part of our work program 2024, where we are now discussing with the stakeholders what it is that we want to do with Japan. And of course, we have to talk to the Japanese actors to be ready around mid-June, June, July. That would be our perspective, to have a clear agenda of what it is that we want to do together in technological terms. So sorry if I was a little bit too long, and I hope it was interesting for you, and happy to answer any question you may have later.
Thanks a lot, Bernhard. It was really very insightful, and also I think touched upon many aspects that I had already mentioned in the introduction, and many critical aspects also that are yet to be defined. Thanks a lot. Yeah, so this brings us to you, Aki Nagaho. I'll give first a brief introduction. You hold a degree in physics from the University of Tokyo, and then you did a master's and a PhD in computer science from Princeton in the US. And from 2019 to today, you have also served as Vice Dean of the University of Tokyo's Interfaculty Initiative in Information Studies. In April 2021, you've moved to the School of Engineering, always at the University of Tokyo, as a professor. And you also hold several other roles as, for example, special advisor to the president of the University of Tokyo, as a director in the Collaborative Research Institute for the Next Generation Cyber Infrastructure, also at the University of Tokyo. You were also appointed as chairman of the 5G Mobile Network Promotion Forum, Network Architecture Committee by the Japanese government. And you are also acting as chairman of the 5G and Beyond 5G Committee and the Space ICT Promotion Initiative Forum in the International Committee, and also Beyond 5G Promotion Consortium, as well as the Japanese, and you are also, sorry, you are also chair of the Japanese Institute of Electronics, Information and Communication Engineers, and they're in particular in the Technical Committee on Network Systems. And you're also chair of the Technical Committee on Cross-Field Research Association of Super Intelligent Networking. So a number of very important appointments. And yeah, now we look forward to hearing from you how you see the space of 5G and 6G evolving. The floor is yours.
Okay, thank you. Good afternoon. I'm Aki Nakao. I'm teaching at the University of Tokyo, and I'm honored to be here presenting my view on 6G to you, and I'd like to get opinions from you too. So thank you very much for the very long introduction. Maybe my sec put a lot of things on the list. So please, can you put up my slides? Yeah, thank you. So because there is a very nice introduction, so I'm skipping these slides, but just to mention that I have to use this picture of myself because I hired a professional photographer. And it was a great investment, so I have to use whenever I have opportunity to use that. So but later maybe you can read out my various hats that I'm wearing at various places. Okay, so I think everyone knows that what G means. G stands for generation. So our telecommunication area. So generation means 10 years. So we started out beyond 5G R&D at the year of 2020, and we expect to see 6G coming in 2030s. So for that, as Bernard pointed out, we have to start now because in 2025, 3GPP standardization is going to start embody what's coming in the 6G in the real world. So we are quite excited about this R&D because we started seeing a lot of opportunity for a next generation cyber infrastructure and the use cases. So this is our vision we created in 2019. And all the professors got together at the Ministry of Internal Affairs and Communication, and we decided the 7 directions of technologies that we would like to achieve in 2030s. So if you look at the 3 boxes, blue boxes at the very top, ultra fast and large capacity, and ultra low latency, and ultra numerous connectivity. So these 3 features are just extensions to what we have in 5G communication. So we like to further upgrade the 5G features in 6G too. But if you look at the 4 boxes, orange boxes down below, we added the new KPI, the ultra low power consumption, ultra security and resiliency, and autonomy and scalability. So among these 4 new value added features for 6G, so I'd like to stress that ultra security and resiliency is very important because right now we are using encryption in the internet communication, but all the professors in the world predict that this is gonna, this encryption scheme is gonna break in 2030 already. So because the public key infrastructure, it's not gonna work if quantum computation comes into play. And we have to find a new scheme to protect our data flowing into in the internet. And autonomy, so Bernard already mentioned that AI, so we have to borrow the power of AI and machine learning to compensate for the human ability to manage network and operations. And scalability, I think the general public understands this part very well because we have to have a seamless outer coverage of telecommunication using satellite communication and HAPS. HAPS stands for High Altitude Platform Stations. So this is like a glider, balloons, all kinds of like a spaceship. So we can use that for communication. So we are adding the vertical direction, not just the horizontal communication. We have to use whatever we can use to enhance the scalability of telecommunications. So these are the 7 directions that we foresee coming in next generation telecommunication. So can you go to the next one? Okay. So for that, so we formed the Beyond 5G Promotion Consortium. So Ministry of Internal Affairs and Communication built this structure. It's quite complex structure, but I'm chairing the international committee. This is the perfect role to explore the collaboration between the EU and Japan. So we have several subcommittees under Planning Strategy Committee, which is led by my colleague, Professor, and an international committee I'm leading this one, but under that we have several subcommittees: white paper, open RAN, technical working groups, and international advisory board. So I don't have much time to cover everything, but we published the white paper in, I mean, it's already version 2, but okay, it's not, clicker is not working. So, but you know, I can just mention that our mission of International Committee is the following. So we have 2 missions. The first one is introduce our activity as well as grasp the global landscape of beyond 5G to identify the strong partner to collaborate with. So we already signed up an MOU with the 6G flagship and 6G IA, NextG, and Power. And so I think Bernard already mentioned that 6G IA partnership is already established. So we are trying to identify the common vision and the items that we can work together on. And the second mission is to quickly establish coordination on R&Ds that requires tight international collaboration. The scalability, like NTN, non-terrestrial network is one, securities is another one, and the high frequency band. So all these technical aspects, we formed working groups: scalability, security, high frequency, autonomy, and time synchronization. So this needs the international cooperation because, you know, Japan is a small country. We can't, you know, build up this technology by ourselves. So for that, we try to establish MOUs with various organizations, Finland and Europe 6GIA, I already mentioned, XG and Power Project from the United States. And we are trying to extend the reach of our cooperation now. So we have, you know, still HexX project and 6GIC from UK. So we'd like to, so in fact, we are already talking about a collaboration. And I became a visiting scholar in the University of Surrey. Rahim is leading this 6GIC. So we will see MOU coming probably soon. And go to the next one. So you can quickly flip the slides because, you know, I don't have much time. So this is a flagship, you know, 6G flagship with Finland MOU, and the next one. So my clicker is not working, so maybe you can please click on that. 6GIA, and the next one, please. And NextG Alliance. You know, you will get all these slides later, so you know, we can just quickly go over it. And please go to the next one. Next one. So we had a Beyond 5G International Conference last year in October. So we invited lots of my, you know, our friends, and we discussed this international collaboration in the future. Go to the next one. So then we can just, you know, explain a white paper that we published. Please go to the next one. So this white paper, I like to mention that it's quite different from ordinary white paper. So it starts with the traffic trends and market trends and trends from other industries before talking about 6G technologies. So we list up all the use cases, we talk to verticals, and then from those use cases, we extracted this KPI of technology. So it's quite you know, different structure from ordinary white paper. What's the next one? And I talked about a KPI of 7 directions, but in this slide, we have 3D holography, autonomous construction, zero-touch autonomous operation, implant devices, HAPS, and coverage on the moon. So we are talking about a moon. And well, so the moon, we are exploring the water by terahertz sensing project, for example. So you know, it's quite imaginative, but it's you know, we are very quite serious about this. And mission critical communication also. Flying car example is another one. So go to the next one. Okay, so I'm skipping a little bit of the next topic, because this is Open RAN, quite technical, but please go to the next one. So probably Open RAN is not happening in all over the world yet, but this is unbundlement of mobile network infrastructure components. So by this, we can create a new stakeholder for and establish a new ecosystem. And then also we can achieve national economic security by doing that to ensure the supply chain by a multi-vendor structure of the mobile network infrastructure. So please go to the next one. So we sign up for this Open RAN with various countries already, US, Australia, and India. So it's called a Quad Agreement on Open RAN. So this is another collaboration possibility as well. Go to the next one. And we have a Japan OTIC testing and integration facility. So for testing the various equipment, working together. So we have to have a center, and the US already established, all these OTIC facilities. And Japan, this is not, the first Japanese one. Last year, December 20th, we started this one with all the 4 telecom carriers. Okay, go to the next one, please. Okay, so now talking about a budget. So Bernard said at 900 million euros for SNS, but the Ministry of Internal Affairs and Communication promised us to invest $1 billion USD, which is a very big amount of money, but up to now, so they keep up their promise almost. So in 2021, they invested 231 million US dollars, and this coming spring, they already secured 625 million US dollars. So in total, so it's something like 900 million, US dollars, which almost matches up with the European project as well. So, but if you look at this chart, so by the year 2025, so we'd like to finish the R&D of core technologies. So we have only 3 years left, before them. So we have to, run as fast as we can. Okay, go to the next one. So, and then we have R&D on international cooperation. So right now, 3 projects are running, and 2 of them are running between EU, terahertz network, and open and secure beyond 5G mobile data offloading using Wi-Fi and other technology as well. But only 2, so we have to see more EU-Japan project coming. Please go to the next one. So we have, projects funded in 4 categories: the core research and foundational and general program, international joint program, and the program for technology and idea creation, small projects. And go to the next one. So you can see that all these projects are covering the different areas of technologies like service application, digital twinning, AI, IoT, edge cloud, non-terrestrial network, and optical communications. So, and if you look at the international joint program, so we have a scarce area there. So we have to fill these gaps to, enhance the international cooperation. Okay, so this is the very reason why I'm here. And please go to the next one. So I'm, using up the little bit of time to introduce our projects. So please go to the next one. So we have quite a few national projects running in my lab. So I don't name all of these, but you can see IoT, CPS, and IoT auto coverage, smart urban communication, and satellite communication, all these items. So I can pick up several because due to the time constraint, I can introduce some of them. Please go to the next one. So the first one, do you know this mountain? But do you know that the non-cellular signal coverage is there yet? So it's only a 1.5-hour train ride from Tokyo. If you go there for sightseeing, so you are out of connectivity. And there are still more than 100 people suffering from the climbing accidents every year for the past 10 years. So go to the next one. So we took this situation very seriously, and we embedded this local 5G connectivity together with satellite communication provided by Starlink. And look at this buggy. So that's my car. And we loaded up the satellite dish antenna and the local 5G base station together. And if you go into the mountain and use this backhaul of a local 5G. Local 5G is, by the way, private 5G network. And coverage is all over Japan now. So you can go anywhere that has no connectivity yet, but you can create the connectivity coverage wherever, even in the mountain, in the ocean area. So, and we did this experiment last year, and caught a lot of attentions from the industry, because this is the future if you want to cover the deserted area. Go to the next one. And also now this is a different project, but this project is with the Rakuten. And the idea here is that we want to use our regular phone. So if you are operating your own smartphone, but if you bring this into the mountain, there's no signal coming. But using the satellite, not dish from the Starlink, just the regular phone, so we can provide a mobile direct, meaning that you can use a regular phone, unmodified, can get connected to the satellite. How can we do that? So look at this satellite picture. So we can use the gigantic antenna to capture your signal from the very small smartphone. What is the size of the antenna? It's a basketball size. You can play basketball on this antenna. But if you load up this antenna with the satellite, so then you can get the smartphone signal on the antenna. So go to the next one. Okay, so the architecture is like this. So you see from this picture that you can use the user equipment directly going to the satellite, coming down and get to the internet. So people might laugh at this picture. It's crazy, right? Crazy scientists can bring up this idea, but we are serious. And we already launched this satellite, and it's a testing satellite, but this is the outer coverage, what it means by outer coverage. Okay, go to the next one. So I just want to say a little bit about local 5G. So local 5G is a new strategy that the Japanese government started. So it's a private 5G, but regular people like us can get the license and operate our own 5G network. So I'm using this for Mount Fuji use cases. Okay, go to the next one. So do you know Nakao Lab local mobile operator? There's no such thing in the world, in Japan. This is the base station that I developed and operate by myself. You can do this kind of thing, right, and bring it to the Mount Fuji. Okay, go to the next one. And unfortunately, I provided my slide in PDF format. You can't see the movie, but this is the holography digital twinning. Maybe I have a chance I can play that video later. But my student has developed these 4 cameras perfectly aligned in a few minutes, and then you can capture, the image of yourself. And this 3D capture holograph image can be sent over local 5G network because we have a lot of bandwidth to send at point clouds, right? Okay, next one. This is my last slide. So, so this is the project I ran with help from my friend Bernard, the 5G Pagoda project. So he mentioned that the pre-standardization activity, this is exactly pointing out that aspect. So this is the EU-Japan project, but we did over 100 pre-standardization activities. Actually, we submitted over 100 the 3GPP contributions from this project. We are doing research on a network slicing there. So I think this is a good example, but so this started in 2016 and ended 2019, and we have to have the next one with EU. Okay. In summary, this picture tells you everything. We have to have a project. Thank you very much for your attention. This is the end of my talk.
Thanks a lot also for this very insightful presentation. And now we are in a slight delay, but nevertheless, we have enough time to do a round of question and answers. So I'm looking already around in the room if there are any questions already. Yeah, we already have a question here. Okay. No, please go ahead. I would have a backup question, but I would be much more... Yeah, okay, perfect, thank you.
Does it work now? Yeah. Thank you. Very, very interesting. Thank you very much. I wanted to ask, well, 20 questions, but I will limit to just a couple. No, just a couple, and you can discard them if you don't like them. One relates to the requirements for spectrum for 6G. Do you think this is going to be an issue because you have the WRC coming up now at the end of this year? I suppose this is going to be an issue that's going to be addressed. Maybe this is something that already has to be looked at in advance to reserve spectrum or identify exactly how that's going to be worked. And then the other thing I wanted to ask you about was the photonics aspect, because you said that this means that we'll require far less power and far less energy, which of course is a big issue in all data production and use and all of telecoms as well. I have another question, but it's perhaps not very politically correct, and that relates to the security. You've seen already from the Munich security conference, there's a big discussion about Huawei, and this comes up over and over again, so I don't know if you want to address that, but that's another issue relating to the Chinese participation and cooperation, which of course existed with 5G too, but I keep my other questions for you.
Okay, yeah, it might be a chance. Let me see if there are
Other questions,
check if there are other questions for now.
Maybe we can take the first round of questions, you can reflect a bit, and then we'll open.
Yeah, ça marche? Oui. It works. Yes, in terms of spectrum, my understanding is that there may be different views all over the world on that. I mean, we have heard, for instance, the US stating that already in the context of 5G, there is a need to extend the discussion to frequency bands between, I don't remember, 7 and 15 gigahertz, something like that, somewhere in the KU, in the classical KU band, which probably will not be easy in Europe. I'm not 100% sure what I'm saying, but these are frequency bands where there are a lot of satellite usage, for instance, KU bands, so it's not necessarily something which is going to be easy to accommodate from a European perspective. There are discussions also to grab some parts of the C bands at 6 gigahertz for, I think, for Wi-Fi usages or for type of 5G-like type of usages, which in Europe I think will be difficult to accommodate again. So again, not necessarily the same alignment between US and Europe. And now if you look more into the 6G type of storyline, there is a requirement to move towards a terahertz band. That means, or sub-terahertz band, between 130 gigahertz and 300 gigahertz, to provide a couple of things, which are very accurate positioning, because when you move higher in frequency bands, you can have a very high precision positioning. We heard the Galileo colleagues stating a couple of weeks ago on the occasion of the space conference that now Galileo has opened the service for 20 centimeter positioning, the so-called PRS service, but here we are talking about centimeter type of positioning. This frequency band is potentially interesting from the perspective of sensing, because you can use a telecom link as a radar link as well, so you can kind of cartography the landscape. You can see if there is a wall, if there is a person, if there is a chair in front of you. And the last element is that it provides huge volumes of capacity. So if you want to make a digital twin of this room, for instance, you will need terabit per second. You will need huge volumes of capacity. I think there is a nice white paper by Samsung that looks at the various capabilities you need when you want to generate the digital twins. You need huge volumes of capacity, which is not compatible with the bands which are existing today. Even the 5G bands, which go, if I remember well, up to 90 gigahertz. I think it's what is in the standards. So that's the first element. So we are looking into this type of things. Now, you may want to say, yeah, but millimeter wave has not taken up. So how comes that terahertz will take up? It's not exactly the same type of applications, and we expect at least that for some fixed wireless type of access, or in Europe, we are looking into millimeter wave bands in the case of 5G. For industrial type of applications, or private 5G. So we believe that there is a potential here to stimulate the market to take up with this frequency band. Of course, in Europe, it's complicated by the fact that different member states don't have the same licensing systems. You have Germany, where they have identified specific bands. In other member states, it's a little bit different, and the licensing is not necessarily fully harmonized. Now, in photonics, when you mention photonics, from our perspective, we are very much interested in the Japanese program, which is called IOWN, Integrated Optical Wireless Networks, I think, something like that, where they are, if I understand well, but Haki can probably say more clever things than me on that, they are looking into how to merge the photonic technologies with the wireless technologies to combine the efficiency and possibly also to bring down the power consumption. But I would tend to believe, and this is under discussion in the community, that when we talk about energy efficiency, the main gains are not in the networks. The main gains will be, at least that's the perspective we are working on, the main gains will be on how the network is used to enable a specific use case to save energy. For instance, if, I don't know, connected cars are running on top of a 5G or 6G platform, the 6G platform should enable the automotive use case to save 30% of fuel or 30% of electricity by providing an optimized route, or by guiding the vehicles in the best place, by optimizing the journey of the cars. And that kind of model we are trying to replicate in industrial use cases or in healthcare use cases. Now, on the last one, in terms of security, what you mentioned about all this discussion about the so-called high-risk vendors, we have an approach which is, because what you mentioned is related to security of the supply chain, to have alternative vendors, which is very much connected to the Open RAN discussion that you showed. And in our perspective, it's very important, of course, to have diversified supply chain, but our position is that we need diversified supply chain, not only at the level of the telecom vendors, but at each and every levels. And that's one of our, let's say, question mark at this moment in time with Open RAN, is that we have sometimes the feeling that if we open the supply capabilities at a certain layer, we potentially initiate some lock-in at the microelectronics layer. Because when you look at the virtualized platforms which are running today in networks, they are provided by one supplier, which is not open, by the way. If you want to push an accelerator in this platform, it will tell you, no, it's not my ecosystem. So we have to consider how we increase or we decrease the security risk by providing alternative suppliers when it is needed, but at each and every layers, at the cloud platform, at the microelectronics platform, at the connectivity platform. Not only at the connectivity platforms, as we have the impression sometimes the Open RAN discussion is focused on. Voilà.
Bernard answered everything. So I can add a few things in three aspects. The first one, frequency band coordination. I think, so frequency band is like land. So if you want to allocate, I mean, if you want to go for a large capacity, we have to go higher frequency because lower frequency band is already used up. I mean, it's very crowded. It's very easy to use. So you have to go up in a high frequency band. And large capacity comes from, large bandwidth in the frequency band. So that's why we have to coordinate on the high frequency band in future. Sub-terahertz is one, but it's very hard to use sub-terahertz, 100 gig to 300 gig for communication. But for sensing and the location, like Bernard said, very accurate, like a centimeter, millimeter, fine grain location is possible with very high frequency band because you can measure timing if you use very high frequency band. So then you can use use very sharp timing, and if you take the timing difference, so you can measure the distance, then you can achieve the high accuracy allocation possible. So it's very important to coordinate on this, internationally coordinate on how we use this high frequency band and WRC, we have to agree upon which band to use. That's very important issue. And optical communication, so ION, so we call it ION, IOWN, innovative optical and wireless network. And this is initiated by NTT in Japan, and we take all photonic network is a future architecture. And all photonic, as Bernard pointed out, it's a low power consumption compared to electricity line. But it's harder to do everything turn into optical connectivity because it's costly and we have to lay out a fiber everywhere. But it's worth because you can achieve low latency and low jitter network, which is very critical for remote surgery. So people talk about remote surgery in a white paper, and nobody believed in that before. But now, so NTT demonstrated the real remote surgery using all photonic network. 120 kilometers away, doctor is operating on the remote machine, which is called a hinotori, which is Firebird in Japanese, but it's equipment vendor, Japanese vendor. I actually operated on this over optical link. And very precise movement of your finger can be transferred to the remote machine so that you can do remote surgery. And if you come to Japan, maybe NTT can allow you to do this, operate on this device. Yeah, maybe. but low jitter. Jitter means that time variance in latency. Low jitter and low latency communication is possible with this optical, all optical network. So we expect to see, lots of application using low latency, low jitter communication. by optical network. Also low power consumption as well. And the security, so Bernard said it all, but Open RAN, I mentioned in using one of my slides is like decomposing the mobile infrastructure into pieces. So like Lego blocks. So, Lego blocks, the interface is defined clearly so that Lego blocks can build on top of each other. But if you don't, define a clear interface, open interface, we can't build the Lego blocks into, you can form a shape. But the nice thing about this decomposition of mobile network infrastructure is that you can replace this Lego block easily by another vendor. If you don't like a Chinese vendor, so then you can replace this Lego block with a Japanese vendor as long as interface is clearly defined. So if you want to rule out like, security-wise vulnerable Lego block, you can rule it out and replace it with others. So this interface, definition of this interface is done by Open RAN initiative. So this is, another term. In another term, it's called a multi-vendors, strategy. But you can replace always, this. But there is a challenge here. So interoperability testing is a challenge because you have lots of Lego blocks, but people say that, okay, so this is the interface that you have to stick with. But some vendor may not build a Lego block with that interface definition, right? So Lego blocks cannot, be built on top of each other in this case. So this is the challenge that we are facing, and a testing and integrating center that we built in Japan is called OTIC. That is for this purpose, interoperability insurance. So this is very important for security. Okay. I hope I complemented Bernard's answer a little bit.
I think you did very well. Thank you. Thanks a lot for the answers. I also wanted to reiterate that the online audience is invited to ask questions via the Q&A box. Well, not the Q&A box, like the comments on YouTube. And my colleague Clément is monitoring this box. So also, if the online audience has any questions, please feel free to submit them, and we will voice them out here. Is there any other person that has in the meantime developed another question? Looking into the room. Not so far, so maybe I can slot in one of mine that I have made during the very interesting discussions. We have, or you have both mentioned the memorandum of understanding on 6G cooperation. You also, what I have touched upon earlier, the EU-Japan digital partnership, in which both 5G and 6G are a main priority. But I'm really curious to know what are the next steps with regard to those both documents and even also other agreements that maybe you have formed, especially how to move now from those policy papers, so to say, to practice. And also, given that the priorities are, as we have heard, many, and maybe you can also quickly touch upon industry cooperation or non-governmental cooperation that already exists or that is ongoing between the EU and Japan, and potentially also any other players. Who's going first?
Yeah, should work now? No. No? Yes, it does. Sorry for that. Sorry again for that. So in terms of how to flesh the bones of the digital partnerships, so on the specific issue of 6G, our intention is not to create yet another machinery, but to use as much as possible existing instruments that we have available to make a few things happen. First, to have as much as possible discussion forums, which can be conferences, but which can be specific setups where we can exchange our views on both sides, trying to come together to some conclusions in the context of future systems and what kind of technology, what kind of standards we want to push. And as I said in the introduction, also if we can try to converge towards ecosystems. So for us, these are important framing questions that we would like to convey through a kind of structured dialogue. So to materialize these structured dialogues, we are relying very much on the 6G Industry Association, which is our partner on the private side, to use the umbrella projects that we have to structure this discussion. So as I said in my introduction, we have a so-called flagship project called ExaX with a large number of partners now, which was launched a couple of years ago. And just now we have contracted the second phase of ExaX called ExaX2, which has 44 partners inside. So it's a huge project, but which is also intending not only to design the system perspective of 6G or future beyond 5G systems, but which is also intending to cooperate with other regions and to liaise with other regions. So we are expecting these established initiatives to organize structured discussions with the other regions, also fleshing the bones of the memorandum of understanding that 6GIA has signed with the 5G Promotion Consortium. So for us, it's an important vehicle. Of course, there are other vehicles which are, for instance, regular meetings in the ITU when these type of things are being discussed. So we are trying to put in place a certain set of milestones between now and the next 2 years where we can have synchronization points to exchange our views on that. And in addition, as part of a 2024 work program, as I introduced as well, we are going to discuss with our Japanese colleagues dedicated R&D actions where we could have mutual benefits from both sides. So I'm just saying things which has not been decided yet because we have about 6 months to make this decision before we launch the 2024 work program. But for instance, if there is an interest in open RAN and open architecture, this could be a type of domain where we could work together, taking advantage of the very strong interest on the Japanese side on that, but also taking advantage of the fact that there are a number of players in this ecosystem in Europe as well. So it's just one of the ideas. We are thinking also of looking into this IOWN story, how we could potentially materialize something. But this is still to be discussed with the industry stakeholders and with the research stakeholders.
Yeah, it's a very interesting and a very important question. And so my colleague mentioned to me, Aki, so you are doing lots of MOUs, but those are just a piece of papers. And of course we have to, like you said, flesh out the bonds that we have, MOUs. And for that, I think encouraging investment from both government and also industry is very important. And for that, how can we smartly do that? Bernard mentioned that he has a HexaX flagship project, but we don't have international flagship project yet. For example, EU-Japan. And once we have best practice of EU-Japan project, which is very successful in pre-standardization activity, Open RAN, also security enhancement. Both regions can cooperate on enhancing security of mobile network infrastructure, which is probably very important and also very understandable, easily understandable by both nations, for example. So in order to increase the amount of investment, we have to create this best practice of EU-Japan flagship project so that all the nations can understand, or this is very important for our society, like SDGs that you said. For sustainability of our society, we have to have this technology deployed, as soon as possible. But for that, we need a large investment. It's very costly. So start from very concrete, very good practice, EU-Japan project. Maybe we can be successful and,
Thank you. Thanks. Thank you. Any more questions as we are coming to the closing of the event? Madam, if there's, yeah. Yeah, Andrea, sure.
I'll ask one and then I'll leave it to Megan to ask another, perhaps. So thanks a lot. It is super fascinating, and we could go on asking you questions forever. And this is why we changed the agenda. We're going to stay here for another 4 hours. Okay? No. It's I think what we see is the beyond 5G ushering into a combination of technologies into a very complicated technology stack that needs to be modular, as you were saying, in terms of the Open RAN model and so on. I understand that there might be some divergences as to the security and the viability of the Open RAN model as it stands. And this is, in and of itself, a candidate for further cooperation, because perhaps the model can be improved by removing the bottlenecks, right? But I was wondering whether, well, my sense in evaluating an idea like this is that a project of this complexity requires an enormous budget and demonstration in a cooperative mode. And that you need to also convince stakeholders that the business case is there, right? And there are two things that out of many that I would like to have your comment on. One is quantum cryptography, also because, just for everybody's knowledge, we are about to launch a task force on quantum cryptography, so a working group here at CEPS that will start in a few weeks. And so whether this is an element that might fundamentally change the security, as far as I understand, there's no obvious solution as of today to implement in there. And the other one is perhaps more the layperson's comment. We are in an energy crisis, right? Is the business case seen from today changing if one imagines what the cost of deploying this infrastructure and the associated energy costs would be? Megan, you want to add something?
Well, I wanted to ask a little question relating to your stacks and your Lego analogy, which relates to standardization, because you mentioned how important, but of course this is also important for interoperability, to make sure that all those pieces fit together. And standardization, as you know, is always complex, especially internationally. Have you already started on that, and how are you planning to address that?
I want to add one thing. I want to see the hologram video. I'll stop there.
Okay. So on quantum, it's very quick because I don't have any answer to that. At this moment in time, I know it's, again, it's a research subject which is hitting the limits of range. So there are a number of limitations on how you implement the technology, but this is clearly seen as something super important for the future of networks. And this is definitely a domain where the Commission is investing a lot of money, because it also quantum cryptography also goes with quantum computing. So there are a lot of initiatives in quantum. And again, that's a subject which is very close to the heart of our commissioner. So this is definitely something where we invest a lot of energy, but I don't have real data to give you as to what kind of performances you can expect and what kind of breakthrough you can expect compared to situations today. In terms of energy efficiency, yes, that's a big issue, because what we see is that If we look at mobile communication networks as they existed until 4G, I think it's 70 or 80% of the energy is consumed on the radio access. Now, when we move towards this type of cloud-implemented networks, there will be a huge amount of energy that will be consumed in the computing part of the network, not only on the access part, on the radio transmission part of the network. And there is a trade-off to make per use case on how you use computing, how you use transmission, and how far you use long-range transmission or short-range transmission, or transmission in one frequency band or another frequency bands, and what kind of computing resource you associated to that. So our view, but this is something which is under discussion in industry and in the research domain, is that very much the same as today we have, in terms of network management, we have 5 domains, which is fault, control, administration, performance, and security. We could have another dimension in the future that could be E, that would be an energy kind of management layer that could eventually, per use case, look into the best way of implementing the network characteristics. But this is something which is not done today, and it's really this is really something which is in the research domain. That means how you place the functions, if you handle the traffic more from an edge perspective or more from a data center perspective, and basically how you distribute the functions in the network and what kind of resource you use. This is based on this 6G notion, which is called the computing continuum. That means that from the IoT device down to the centralized data center, you have various computing resources and you use them according to the best efficiency mode. And efficiency should be not translated only in terms of security, administration, whatever, should be also translated in terms of energy efficiency. That's where we are trying to see with the industry if we can add this type of layer. In terms of standardization, that's a very interesting subject, because the specifications for Open RAN today, they are discussed in an alliance, in an industry alliance, which is called ORAN. And ORAN is not considered by the union as a standardization body itself. So what we are doing at this moment in time is that we are setting up a process with ETSI, which is called the ETSI pass mechanism. Don't ask me what it means, but that's the name of the stuff, where we can take specifications originated by ORAN and translate them into European norms. And the moment they become European norms, normally they have the level of stability and the level of interoperability that goes towards a stable implementation. So this is happening today only for what is called the open frontal. That means the interface between the radio unit and the distributed unit. Yes, because this is seen as an important interface for the operators, because this is the interface that they can use to swap equipment from different vendors. So if different vendors have the same interface, you can exchange one equipment from company X with one equipment from company Z. And it makes the interoperability much easier from their perspective. What we are trying to do is that we don't get only the frontal specifications through the ETSI pass, we get also all the accompanying specs which are security related. Because one of our let's say, remarks from the NIS group of member states, which is implemented under the NIS directive, is that Open RAN may come with additional security holes, because the attack surface is increased. So ORAN is working on it and has some specifications. So we try to transfer the whole block of specs into the ETSI machinery in such a way that we have a recognized set of standards that we can play with to say to the operators, this is the set of standards that could be implemented in Europe. Now, if you look at it from the perspective of these many bricks, Lego bricks, which are designed beyond this early set of specifications, to design a full Open RAN, it's clear that there are potential interoperability problems, but if you want, the operators are handling those by opening test centers. So for instance, all the big operators today, they have test centers, and they are running use cases with suppliers in such a way that they can certify the equipment or the piece of software which are provided by different suppliers to make sure that it works from an end-to-end perspective once they have assembled all the bricks. So this is their test and certification centers that they are integrated. There is an initiative which is called the TIP, I think, Telecom Infra Project, which is supporting this type of things. Voilà.
Okay. So about quantum cryptography, so there are two types of technologies existing today. So the one is quantum key exchange, so QKD. So that is, so we use a regular shared key cryptography, but this key is exchanged over quantum mechanics. And the quantum mechanics says that, if you observe the key, if someone observed the key, so the recipient of the key noticed that it's already bleached. So this way you can use quantum mechanics to ensure the secure key exchange, but we can use a regular shared key encryption scheme. So this is already happening, and you can use fiber communication or satellite communication to do the key exchange. This is one type of quantum cryptography, being realized in near future. So another one is more interesting, well, in my opinion. So this is encryption algorithm that is robust against quantum computation. So the encryption we use today in the internet is something like a, computationally challenging. So if you want to break this key, so for example, you and I have a secret conversation and encrypt this conversation, and if someone is interested, they can use all kinds of resources of computational power to break this encryption that between you and me, right? And it's just a matter of cost, right? But so this type of encryption will be broken soon by quantum computation, pretty soon, I would guess. So the researchers now are trying to invent a new scheme which cannot be broken by new quantum computation, for example. Quantum computer cannot break this encryption. So this area is most fascinating and interesting to us. So, and the KDDI, for example, in Japanese company, KDDI is a telecom operator, but they invested their efforts in developing this, quantum craft, yeah. So this is one answer. And the second one, the power consumption. This is an interesting topic too. Bernard already mentioned it. Green transformation, and we have to take this component into account in the development of new mobile network infrastructure. We can't ignore that. So if you want to go after performance, and we cannot use up all the energies on Earth. So we have to. So this is not investment problem. We have to value. That net result we have to consider these days for sustainability of resources existing on the Earth, right? So this is something that we have to consider in the 6G R&D. This is quite obvious. And the last standardization stuff. So as Bernard already mentioned, ORAN is already happening as a project, sort of like a project, not a standardization body. So, but it's quite often, quite frequently being under discussion. So for example, every week, industry partners can get together and discuss what is the right interface between components. So it's moving very, very fast. And it's already deployed, for example, in Japanese mobile base station market. So it's evolving, but at the same time, they implemented the ORAN version of ORAN interface already, and it's being sold today. So some telecom operators can take these ORAN compliant base stations, but of course ORAN specification is evolving every day and adding more features. For example, RAN intelligent controller, which is taking the AI into account in the controller and control the network, mobile network infrastructure by the power of machine learning, for example. So this is, already happening, and we can't stop this activity. But as Bernard said, so we have to think about the future. So if we already have 5G specification, so then we can turn that into ORAN structure, which is we can do today, but we don't have 6G specification yet. So we have to see, how this activity of open interface between the components in new 6G, we haven't seen that yet, but we have to start from now, and what would be the open interface between 6G mobile network infrastructure. That is a big topic now. And for that, I think EU, Japan can collaborate on. We can call it Open RAN++, or we can Open RAN Plus or something like that. Next generation.
Wonderful. Yeah, thanks a lot. With even a bit of overlay, but I hope it's didn't bother any of you, because I see you're a very attentive and interested audience. I will then conclude this event. There's indeed a lot of use cases that we have heard that we think where EU-Japan cooperation, of course, is really crucial for enabling the next generation of 5G and 6G and beyond digital connectivity. And amongst also the geopolitical tension, so to say, I think this collaboration can just be important, and also be wished all the best of luck, and also success, of course, for the next steps. Thanks a lot, and yeah, see you soon at another event, SEPS event.